Welcome to Investigation 3.2. In this investigation, we are going to be investing for the future and looking more specifically at what's called growth rates. Woohoo! Alright, so our focus question for this investigation is the following. How are the growth factor and growth rate for an exponential function related, and when might you use them? So essentially, we are going to be looking at growth factors, which we've been looking at growth factors of like doubling, tripling, quadrupling, and then in the most recent investigation, we looked at a growth rate that was 1.8, and we also looked at one that was 1.2. Well, now we're going to be looking at growth rates and understanding how growth rate and growth factor kind of can work together. So let's understand, first of all, what growth rate is. So growth rate specifically is essentially a percent increase in an exponential that's an A and an L, relationship. So we are looking at specifically, when we think about growth factor, we have a number that we're increasing by. So say we have 10 of something and we have a growth factor of 1.8 over, and it's just, we're looking at 1 year. We're going to be timesing 10 by 1.8 and we'd get 18. Well, instead of writing 1.8, we can essentially also write a percent in there instead and see what sort of increase we have from there. So essentially, our percent increase will be essentially taking into account that we have 10 initially, and the increase that we're adding to get to 18 would be 8, or we could write that as 80%. And so our total overall would still be 18, but that 80% is our growth rate. So let's take this into consideration. Here we go. The bunnies. We got some rabbits happening. So in the last investigation, you guys looked at this exact table and you essentially created it yourself. Or, well, you didn't create it yourself, the book created it for you. So it was looking at this whole concept of growth rate, or growth factor. And now we're going to look at it as a growth rate. So we found that essentially there was a 1.8 growth factor every single year that passed for these bunnies. So they continued to grow at a rate of 1.8, or grow for a factor of 1.8. So the growth factor, we can say, is 1.8. Awesome. Easy. So the growth factor specifically is a ratio of the population for a year divided by the population for the previous year. So essentially, if we wanted to, we can look at the numbers 583.2 if we wanted to. We could divide it by the previous year of 324, and we'd end up with approximately 1.8. As well, we can take 324 and divide it by 180, and again, we'd find a growth factor of 1.8. So that is a ratio of 1 year in comparison to the previous year. So looking at that whole concept and knowing that our growth factor is 1.8 for this particular situation, we can also represent a growth factor as a percent change. And let's do just that. So looking at growth factor as a percent change, let's look at this situation. If we were looking at year 0, we have 100 rabbits, and if we look at year 1, we have 180 rabbits. So we know that growth factor is looking at the change, or it's looking at a ratio between 1 year and the previous year. Well, growth rate, we're looking at 1 year and the previous year, but we're looking more specifically at the change between those 2 years. So what is the increase from the year prior? And then we're going to be dividing that by that previous year. So essentially between 180 and 100, what is the difference there? The difference is, in this case, 80. We're still going to be dividing that by 100, and we'd end up with 80% for our growth rate. And if you remember, our growth factor for this same situation is 1.8. So our job now is to determine how these two things are related. So let's move on. How is that growth factor of 1.8 and the growth rate 80% related? Well, if we look more specifically, this 0.8 right here, if we were to turn 0.8 into a percentage, we would have to move this decimal point over 2, so we'd have to multiply it by 100 and we'd get 80%. Now, my question of you is, where did that 1 go with our growth rate? Where does it go when we look at it from growth factor to growth rate? And so that's something I want you to be conscious of when we're moving on through this. So here's a little question for us. George has a baseball card worth $1,000, $1,000, that his grandfather gave to him to start a baseball collection with. The card increases in value each year by about 2%. Make a table showing the value of the card for the next 5 years. So let's do that. I'm going to make a table horizontally. We haven't done that in a while, where we have our year and we have the dollar value of that baseball card. So when we're starting out, we have just $1,000, but in the first year or the second year, third year, fourth year, and fifth year, we need to figure out how much that baseball card is worth. So if we have $1,000 to start out with, let's create our equation. We have essentially the value of the baseball card is equal to 1,000 as our y-intercept, our initial value, and then we have 2%. Well, let's think about what is 2% of 1,000, and we'll get $20. So if we were to just say 1,000 times 0.02, what 2% equals as a decimal, we are going to end up with a very small number, and we'd end up with just $20. And that's not how much the card is worth after a year. The card gains value of $20 each year. So in all reality, our growth factor, so getting back to what we were talking about previously, is going to not just be 0.02 or 2%, but it also has to include 1. That 1 referring back to the fact that we still have $1,000 in what it's worth. And the 0.2 or 0.02 representing its increase each year. So let's do the math with this equation. We have 1,000 times 1.02 raised to the x power. So if we had 1,000 times 1.02 raised to the first power, we'd end up getting $1,020. So instead of just having $20 in this spot, we're going to write $1,020. Now, the next time we do this, we need to take that same 1,000 and say 1.02, and instead of 1, we're going to put 2 in as our exponent. Another way we can look at this is saying we have this 1,020 already. If we multiplied it by 1.02, we'd find out how much more it was worth. Because we're now not just finding that we're going to add $20 to it, but we have a new initial value, or we have essentially compounded growth. We have that 1,000 that we had for the first year. The next year it's worth $1,020, and that 1.02 is multiplied by that 1,020, which we've been doing this all along whenever we do growth factors. We're multiplying it by 1,020, or 1.02 times 1,020, and we're finding a slightly bigger growth than just $20. So I'm going to do a little bit of math magic and fill in the rest of this table. So here we go. We have the rest of the table filled in. So essentially taking 1,000 and multiplying it by 1.02 squared, we got 1,040.40. So we have $1,040.40 for that card. By the time the 5 years end, that card's not just worth $1,000; it's worth $1,104.08. So we end up getting quite a neat increase with all of this. So it says we need to write an equation describing the changing value of this baseball card. So let's rewrite this equation. We have our value times 1,000 that we're starting out with, and we're multiplying that by 1.02, which is our growth factor, which represents essentially our 2% growth rate per year increase, and that is all raised to the x, and our x stands for our years. So let's keep moving. That is how we can use growth factor and growth rate. And now let's do a little bit of practice. We need to find the growth factor associated with the given growth rate. So we have a growth rate of 10%. There is a 10% increase each year. So if there's a 10% increase, I always like to put this in some sort of context. If I had $100 and I get 10% of that added to this $100, I'm not just going to get $10, but I'll have that initial $100 plus 10. So the way that I can then write that out as a growth factor, the 100 we can write as 1, and the 10 could be shown as 0.1. So we'd end up with 1.1 as our growth factor. Let's look at this 250%. So I'm going to look at this. I have 250%. First of all, we need to put this in some sort of a decimal. We can move this decimal over 2, so we get 2.5. And now let's think, what is 250% increase on $100? So if we have $100 times 250%, we get $250. But we still have that initial $100. So you've essentially invested $100, and your money-making scheme went phenomenally well, and you earned another $250, but that $150 you still initially had. So we could rewrite this as $350. So meaning our growth rate is 3.5. 7% increase. There's no place at 2% increase except for 7. We're going to move our decimal point over. We can rewrite this as 0.07. If it's a 7% increase over our initial amount, we still have that initial amount plus another 7%. So our initial amount is represented as a 1. And then we also have our 7%. So 0.07 is our growth rate. So here's our growth rate, or growth factors for this given growth rate. So let's also try to do the opposite. Find the growth rate associated with the given growth factor. So like before, this 1 was that initial value. So our increase over 1, over our initial value, is represented right here with everything else. So I'm going to actually subtract 1 from this, and I get 0.03, and then this can be turned into a percent because a growth rate is a percentage. So I'm going to multiply this by 100, essentially move the decimal point over 2 spaces, and I get 3% is my growth rate. Same sort of thing here. We have 1.07. I'm going to subtract my initial amount. That's what that 1 represents. And everything that is remaining is 0.7. So that 0.7, another way we can write that as a percentage, it means we're multiplying it by 100, which means we're moving that decimal point over 2 places, and that is 70. So that's a pretty nice return. 70% above what I initially paid. This same one, the 2, we're going to first subtract our initial amount, which is 1, and we end up with just 1. Well, let's move our decimal point over 2 places, so we'll end up with 100%. So I'm not just making money off of my initial investment, I'm getting an additional 100% of that. So my money essentially doubles. So whenever we were seeing a times 2 growth factor, that can be represented by a 100% growth rate. So I hope this investigation and going through all this made a little bit more sense to you. Try your hand at the investigation and the homework. And if you as always, if you have any questions, please ask. Thank you so much for watching, and I'll talk to you later.